Hello students. So in this video I'll be solving some problems on system interconnection. In the previous video we took the properties of LTI system using impulse response. We discussed about that, and in that we've gone through when the system connected in parallel, what happens, and what happens when the system connected in cascade. So the system will possess, that means the overall system function h of n or h of t will be the sum of their individual impulse responses if the system is connected in parallel. So if the system is connected in series, then the overall impulse response of the system is the convolution of the individual impulse responses of the system, that is h of t is equal to h1 of t convolved with h2 of t. And it also says that the system order is independent. That means when we perform this convolution, the system order is independent, which is by the commutative property. That means in the second one, if the system is connected in cascade, it need not be that the first system should be h1 of t and second system should be h2 of t. It might be of any order. So that is the overall meaning of that. Now based on that, we are applying the properties to solve the problems here. So here is a problem. It says a system is given, interconnection of system is shown in the figure which is below, and the impulse responses are h1 of n, h2 of n and h3 of n with their respective values they have given, where h1 of n is 1 by 2 to the power of n u of n plus 2, and h2 of n is delta n, and h3 of n is u of n minus 1 here. So these three. Now the overall impulse response of the system, they are calling this as h of n. Let the overall system response be h of n, for which you get output y of n for the input x of n. Fine. So now we have to perform two things here. First thing is express h of n in terms of h1 of n, h2 of n and h3 of n. And second one is evaluate h of n using the results of part A. So this is the problem, and this is the system given here. Now let's try to solve this. Okay. Now here you can see the system, these two systems are connected in parallel. So that means we will be writing the equivalent system of that. So if the systems are connected in parallel, then the system response will be the sum of them. That means this will be h2 of n, you can see this plus and plus is there, plus h3 of n, because they are connected in parallel. So we are applying the parallel connection property here. So based on that, we can write this as h2 of n plus h3 of n. Okay. So this is the first step of reducing this. Now as you can see, now we got two system. One system is connected in cascade with the other system. Now if you apply the second cascade property here, so you can write that the first one is h1 of n. So cascade property says if the two systems are connected in series, then it will be the system response will be the convolution of that individual responses. This is the impulse response of one system, and this is the impulse response of second system. So based on that, we can write the overall system response in this way. So we have applied the two properties here. So now let's express h of n in terms of h1 of n, h2 of n. So that is the overall system response for which input is x of n and output y of n is h of n. So that is given in the problem. Therefore h1 of n convolved with h2 of n plus h3 of n. So this is what we get. And if you simplify this, so then h1 of n is convolved with h2 of n plus h1 of n is convolved with h3 of n. So this is the first part, expressing h of n in terms of h1 of n, h2 of n and h3 of n. And they also asked to evaluate h of n using the result of this. So therefore, h of n is equal to, let's substitute the values of h1 of n, h2 of n and h3 of n here. So you can see this. What is h1 of n? It is 1 by 2 to the power of n, u of n plus 2. h2 of n is delta n and h3 of n is u of n minus 1. So let's substitute this here. So h1 of n is 1 by 2 to the power of n, u of n plus 2, and this will be convolved with delta n plus again 1 by 2 to the power of n, u of n plus 2 is convolved with u of n minus 1. Okay. Now, if you perform the convolution here, and I'm not going to elaborate on that one, I'll just give you the final expression for this. You can elaborate, you can perform the convolution by applying the properties or by performing the convolution sum operation for these two. You will get the end result, and I'll just give you the final answer here for you to verify. Okay, so this will give you u of n plus 2. So this is by the property of impulse response, so that we can write it like this: x of n convolved with delta n will be equal to x of n only. So based on that, we can write it here like this one, plus, so this part will give you the answer like 8 minus 1 by 2 n minus 1, okay, into u of n plus 1. So this you can verify. So this is you can simply apply this property. I write it here: x of n convolved with delta n is equal to x of n only. So based on this, you will get the same here if you consider this as entire one signal. So this is part is simple, and this you can perform the convolution sum operation, and you can get the result here. Okay, and I'll move on to the second problem here. It says express the impulse response in terms of h1 of t, h2 of t, h3 of t, h4 of t and h5 of t for the system given below. So this is what the problem is. So let's take the system response here. So this one, the system given h1 of t. So they are just asked to write h of t for this thing. Okay, so let's take that one after taking this overall system problem. So we have to reduce this to get the expression for h of t, and there is nowhere the what is h1 of t, h2 of t, that is not given here. So the sign is plus here, and this part again we have to add these two. The system output is again getting, it is added here, and the sign is minus here, plus and minus, and again it is going through one more impulse response h5 of t y of t. Okay, so this is the system given for which we have to express h of t in terms of h1, h2, h3, h4 and h5 of t. So let's start reducing this. Now if you look at this, we have two systems connected in parallel. Try to minimize which are connected in parallel first. So this, if you take this, for these two systems the input is x of t only, so the impulse responses are connected in parallel. So if you minimize this by using the parallel connection. So then the system will look like this. I am minimizing this. So this is my H1 of t, which is connected to H4 of t, and the system input here is x of t. Okay. Now these two are in parallel. That means it will be the sum of these impulses h2 of t plus h3 of t. So why I have written plus here? We have to perform addition since both are having plus and plus here. So that's why h2 of t plus h3 of t. Now this is again we are to add here. So this is h5 of t and this is the output. Next step. So these two are connected in cascade. Let's reduce that. So if you reduce that, then it will be h1 of t convolved with h4 of t. So h1 of t convolved with h4 of t. So this is the first system which is reduced, and below this we have the same h2 of t plus h3 of t. You can do the both operation in one step only, but you have to mention that the first one we are performing is the parallel operation, and second one we are applying the cascade connection relation or property of that, and we are reducing the impulse response in this way. Okay, and now these two are added here. So plus minus, and for this we have h5 of t and the output y of t. So now considering these two again, these two responses are connected in parallel, and let's reduce that as well. So if you reduce that, so you'll get the expression like h1 of t convolved with h4 of t. Okay. Now this one is plus, and here it is minus h2 of t plus h3 of t. So this is the overall system response when it is reduced to by applying the cascade connection, parallel connection property, for which the input is same, and this is being connected in cascade with h5 of t to get the output y of t. Okay. So finally we can reduce this since these two are connected in cascade. So by applying that, we can get the overall system response like this. So h1 of t convolved with h4 of t minus h2 of t minus h3 of t. Okay. So this whole thing is getting convolved with h5 of t. To get y of t. So this is the final reduction of this, or final equivalent circuit we have written, and based on this we can write h of t is equal to h1 of t convolved with h4 of t minus h2 of t minus h3 of t. So this whole thing is getting convolved with h5 of t. So this is the system impulse response for the given system. So and this is the equivalent circuit. So this is the equivalent system for this, which system impulse response h of t is equal to h1 of t convolved with h4 of t minus h2 of t minus h3 of t whole convolved with h5 of t. Hope you have understood the step, and in the next video I'll take some more example on this interconnection of system, and I'll give you some problem for you to try at home. Okay, thank you for your time, and if you have any queries, do reply or comment in this video. Thank you.